Today we're going to talk about greatest common factors. So in your table of content, you should put the date, greatest common factor, and it should be on page 4. You can abbreviate greatest common factor as GCF if you don't want to write out the 3 words. So on page 4, the top, put greatest common factor or GCF. So the greatest common factor between numbers is the largest factor they have in common. And there are 3 ways to find the GCF. So the first method is to list. And you can use the UT method to list. Now, this method most of you guys already know. I would not say that this is the fastest method, but it is one way you can find the GCF. So let's say, for example, we want to find the greatest common factor between 24, 48, and 36. Okay, so we first need to list all the factors of all 3 numbers using the UT method. So first I'm going to put 24 above the T. I'm going to put 48 above the T and 36 above the T. Okay, so let's start with 24. What are all the factors of 24? You always start with 1. Okay, 1 times 24. That's 2 factors. Then you go on to the next number. Does 2 go into 24? Yes, it does. 2 times 12. Does 3 go into 24? Yes, it does. 3 times 8. Does 4 go into 24? Yes, 4 times 6. Does 5? No. Does 6? Yes, but if I write 6, I'd put 4 again, and I've already started over. So once you start over, you put the U around it, and then you're done. That's why it's called the UT method. 48. What are all the factors of 48? 1 and 48. 2 and 24. 2 times 24. 3 does go into 48. Think about your divisibility rules. 4 plus 8 is 12, and 3 goes into 12. So 3 does go into 48. 3 times 16. 4 times 12. 5 does not go into 48. 6 does, because you can see 2 and 3 already do, and that's the rule for 6. If 2 and 3 already go into 48, 6 does. 6 times 8. 7 does not. 8 does, but once I put 8, I'd have to put 6 here, and we've started over. So then you put the U around it. We're done. Okay? Last one. 36. 1 and 36. 2 goes into 36 because it's even. 2 goes into 36 18 times. 3 goes into 36, 3 times 12. 4 goes into 36, 4 times 9. 5 does not. 6 does, because you can see 2 and 3 already do. So 6 does. 6 times 6. And then we've started over, because 6 started over. Put the U around it, and we are done. So now let's look for all the common factors first. What factors do they have in common? What are they all divisible by? Well, they're all divisible by 1. But all numbers are divisible by 1, right? 1's a common factor for all numbers. They're all divisible by 2. They are all divisible by 3. All divisible by 4. They're all divisible by 6. They're not all divisible by 8, just these 2. They're all divisible by 12. And these 2 have a common factor of 24, but not this one. So we stop at 12. So all the common factors, all the factors they have in common are 1, 2, 3, 4, 6, and 12. The greatest common factor, the largest number that can go into all 3, the greatest common factor is 12. So that is our greatest common factor for those 3 numbers. Now, like I said, you guys probably already know how to do this method, but it just takes a long time because look how long it took me. I had to do it for 3 different numbers, and they all had a lot of factors, so it took a little longer. So now I'm going to show you method 2. I'm almost out of room, so I'm going to start method 2 on the next page. Okay. Method 2 is inverted division. Inverted division is kind of like upside down division. Inverted division is like upside down division. So let's say, and let's do an example. Let's say I want to find the GCF, greatest common factor, for 120, 56, and 64. Okay. So, using the inverted division, instead of doing my long division this way, I go upside down. I put the numbers in here. That's 120, 56, and 64. Okay. And I think of a number that can go into all three. And it could be any number. You can start small. They're all even, so we can start with 2 if we wanted to. 2 goes into 120 60 times. 2 goes into 56 28 times. And 2 goes into 64 32 times. Let's keep dividing. What goes into 60, 28, and 32? And we can do 2 again because they're all even, right? If you can think of a larger number, you can do that as well. I'll just do 2. 2 goes into 60, 30 times. 2 goes into 28, 14 times. And 2 goes into 32, 16 times. Can we keep dividing? Is there another number that goes into 30, 14, and 16? Yes, there is. You can do 2 again. 2 goes into 30, 15 times. 2 goes into 14, 7 times. And 2 goes into 16, 8 times. And then, is there another number that goes into 15, 7, and 8? Well, the only one I can think of is 1. We could divide it by 1, but if we divide it by 1, we're going to get 15, 7, and 8 again. So when there is no other number that can go into all the numbers besides 1, we are done. So you put the big G around it, G for GCF. And what we do is we take these side numbers and we multiply them. 2 times 2 times 2 equals 8. So the greatest common factor, the largest number that can divide into 120, 56, and 64 evenly, is 8. So the GCF equals 8. That was a lot faster than the UT method, huh? Most kids like this method. I'm going to do one more method, which is method 3. And that is the prime factorization method. You use the prime factorization of the numbers to figure out the greatest common factor. So that is method number 3. Now, kids don't usually like this method, but it is very helpful. Prime factorization can be used to find greatest common factor and then least common multiple when we talk about least common multiple. So the prime factorization of a number tells us a lot about that number. So let's do an example. Let's find the GCF for 36, 64, and 90 using prime factorization. So what you're going to have to do first is find the prime factorization of each number. So that's what I'm going to do. So the prime factorization of 36, I'm going to branch out. I'm going to do 6 times 6, branch out some more, 2 times 3, 2 times 3. Prime, 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 and prime. Okay? So the prime factorization of 36 equals 2 times 2 times 3 times 3. For 64, prime factorization of 64, well, we do 8 times 8, branch it out. 2 times 4, 2 is prime, 4 is not, branch it out. 2 times 2, done on this side. And then finish off on this side. 2 times 4, 2 is prime, 4 is not, branch out. 2 times 2, done. So the prime factorization of 64 is 2 times 2 times 2 times 2 times 2 times 2. And I know I can write 2 to the 6th power, but to find the greatest common factor, I'm going to leave it kind of long. So there's that one, and there's that one. Okay? So now for 90. For 90, I'm going to do 9 times 10. And then 9 branches out to 3 and 3. 3 times 3. Those are prime. And 10 branches out to 2 times 5. Prime and prime. So the prime factorization for 90 is 2 times 3 times 3 times 5. Okay? So those three are the ones I'm going to use. So here's the thing about prime factorization. You can look at a number's prime factorization and find all the factors of 36, all the numbers that can go into 36, just by looking at the prime factorization. So for example, I know 2 can go into 36 because 2 is in the prime factorization. I know 4 can go into 36 because look, 2 times 2 is 4, so 4 can go into 36. I know 3 can go into 36. I know 9 can go into 36 because 3 times 3 is 9. I know 6 can go into 36 because look, 2 times 3 is 6. So I can use the prime factorization of a number to figure out all the factors of 36, all the numbers that can go into 36. Okay? So when I'm trying to look for the greatest common factor, you can see that they all have 2 in common. So 2 goes into all the numbers. But is that the greatest common factor? No. Right? So let's see, what are all the numbers that go into all 3 numbers? They all have a 2. They all have, well, actually they don't have, this one does not have a 3. These 2 have 3s, right? And this one has a 5. So the only number that they actually have in common is 2. So the greatest common factor is 2. I didn't pick a very good example here. Because the greatest common factor, the only number that they all have in common is 2. So therefore, the greatest common factor for these 3 numbers is 2. I'm going to do another one because that was not one that had a really big greatest common factor. So let's try another one. Let's do another one using prime factorization. Okay. So let's do our example from inverted division, actually. So I can show you that we can use inverted division to solve these 3, but we can also use prime factorization. Okay. So let's find the GCF for 120, 56, and 64. So first we're going to use prime factorization. So 120 branch out, that's 12 times 10, branch out. 2 times 6, 2 is prime, 6 is not, branch out. 2 times 3, prime, prime. And then the 10, 2 times 5. Okay, so the prime factorization of 120 is 2 times 2 times 2 times 3 times 5. Okay, now for 56. Prime factorization of 56, 7 times 8. 7 is prime, 8 is not, branch out. 2 times 4, 2 is prime, 4 is not, branch out. 2 times 2, and we are done. So the prime factorization of 56 is 2 times 2 times 2 times 7. Last one, 64. Prime factorization of 64, 8 times 8, branch out. 2 times 4, 2 is prime, 4 is not, branch out. 2 times 2. And then this side. 2 times 4, 2 is prime, 4 is not, branch out. 2 times 2. So the prime factorization of 64 is 2 times 2 times 2 times 2 times 2 times 2. Okay? Now, let's look and see what numbers they have in common. They all have 1, 2. They actually have more than 1, 2 in common. They actually have 3 2's in common. See? They all have 3 2's. Anything else that you see that they have in common? I only see the 3 2's. And what is 2 times 2 times 2? It is 8. That means 8 can go into 120, 8 can go into 56, and 8 can go into 64. So the greatest common factor for these 3 numbers is 2 times 2 times 2, which equals 8. But we did that using inverted division as well. Okay, so the inverted division is faster, but we can also use prime factorization to solve it, and it gives you the same answer.